Hey, my name is Craik, and this is Yiğit Boyar.
Hi, today we are going to talk about paging. Even though the title says it's efficient lazy loading with RecyclerView and Room, this actually turned out to be a talk more about paging because when we started this project, we actually then later on realized this is a very complex problem domain. So we wanted to walk through these problems and then talk about our solutions and how we address those problems. Okay, so this is like a list of things in RecyclerView or a list view. I'm pretty sure all of you are familiar with this. But most of the time in reality, this is only the UI section. You have some of this data in memory, and then you probably have more of this data in the database, and then even more in your backend server. And the data like somehow flows from your backend back to the user's UI through different stages. So on Android, since version 1, there is this class called Cursor Adapter. And the Cursor Adapter is designed to solve this problem. If it has been there for such a long time, why are we still talking about this? Like, what can be wrong with this 10-year-old class? To talk about what might be wrong, let's talk about what Cursor Adapter is. Cursor Adapter is a very thin wrapper around cursor. It actually doesn't really do much. It relies on cursor to do the work. Each row is bind to an item from the cursor. And when you're binding your RecyclerView, you access the cursor directly to grab the information you want. And when the cursor doesn't have that information in memory, it will basically go to the database, grab a new page, and present it back to you. So the API when you are using Cursor Adapter looks like this. Every time a bind call comes, the cursor gives you data, and you bind, it gives the data. And this is what you use in the API. But that's not actually what happens behind the scenes. Because going to the disk for data is a relatively expensive operation, Cursor Adapter uses Windows to load this data. So the very first time you call bind, if the window is empty, it goes to the database, queries the database, and fills in a window. And then the consecutive bind operations are very fast because it's coming from the memory up until you reach the end of this cache. Now it needs to go back to the database again, load a new window of data, then the next binds will be fast again. So Cursor Adapter has a bunch of issues because of this approach. First of all, it's an unreliable performance. When the bind is called and you're trying to access the cursor, you have no idea if it's an instant access to memory or potentially very slow access to the disk. The only thing it provides you is a cursor. It doesn't say what fields it has, like what types they are. It's a very undefined, loosely coupled API, and that's actually not what you want in your adapter code. And the cursor, because talking to a database, it has a lifecycle that needs to be managed. Cursor Adapter doesn't really do anything about this. So this summer, we released Room Persistence Library as part of architecture components. And as any other persistence library solution, Room needs lazy loading, a way to provide lazy lists because you're potentially observing large queries. And every time that query changes, you really don't want to rerun this whole query and bring everything back to memory again. And right now, or the very first versions of Room, the only thing you could do was divide the query into pieces by hand, which is like almost impossible to manage. When I was going to implement like lazy loading for Room, I looked at the other object mapping solutions on Android, see how they're implementing this. Almost all of them has this solution where they have a class called lazily or something similar, which extends abstract list, overrides the get method. It looks like this. Like when you try to access a position, it checks the cache. If it is in the cache, it returns from the cache. If it is not in the cache, moves the backing cursor to that position, converts it into pointer, and then returns it. Now it's nice, it's not returning you a cursor anymore, it's actually giving you a pointer that you can safely access. But this method call is potentially dangerous because you don't know, again, if it's a memory access or it's going to disk. So the API looks like the one on the left. You think you're accessing them one by one, but the actual behavior is the one on the right, where you access big chunks of data as you need. So this is how it is defined, and we cannot really change it because that's the best way to access I/O is to do it in chunks. That means room doesn't really need lazy loading. What it really needs is paging, to be able to page those cursor windows into memory efficiently. So when we start this problem, okay, like room needs lazy loading. Good news, RecyclerView has this class called SQLiteUtil that's specifically written to address the shortcomings of cursor adapter. Like, perfect. I'll just implement it and we'll be done. So we'll have in our DAO, we can just say, give me an SQLiteUtil, the same way all other room functionalities work. So I was looking at this, okay, how do I implement this? What do I need to construct an SQLiteUtil? There's two things. There's one data callback and also the view callback, which makes sense. This is what the overall class structure looks like. If we deep dive into the data callback, the part where it acquires the data, it has this method called field data and is given an output array. It's basically responsible to load the data wherever it finds and put it inside this array. So this data callback doesn't really own the data, just knows how to provide it. If you go back, look at the view callback, it has this other method called getItemRangeInto, which is supposed to talk to the view and acquire the first and last visible item position so that SQLiteUtil can decide which to page in. Okay, this is good, but you cannot really implement this view callback without having access to a view. So there comes the question of data ownership. Who owns this data is the SQLiteUtil. The SQLiteUtil class is the one that's holding on to your data. But to initialize the SQLiteUtil, you need the view callback. So by induction, you need UI to own the data. Now, shame on myself because I worked on that class, and this is a horrible way to structure things. Like when sometimes we do this mistake, you're trying to make something easy, and then you forget that that's not a great solution. So the love affair between room and SQLiteUtil didn't last long. Meanwhile, as I was trying to figure this out, Chris was working on RecyclerView prefetching, trying to optimize it. And it's actually a very similar problem domain where you're trying to warm up the things that are about to be visible. So we'd always exchange ideas. When I realized that room doesn't really have an immediate solution, I tricked Chris to work on room. I think that's the same thing.
Somehow you phrase this as a RecyclerView problem entirely, and it just sold me.
So it has nothing to do with room.
All right, so you talked a lot about the problems with async list util and the state of the world with cursor adapter, but there's still this paging implementation inside of SQLiteCursor, the actual API by which you access queries from SQL and Android. And so let's look a little bit deeper into that and see what we might do with it. So SQLiteCursor has a paging implementation inside. You mentioned some of this, that it has a cursor window, a 2 megabyte buffer that it will load in chunks. Rows inside that are efficient, rows outside that, you gotta reload. So we just asked, okay, well, we know that we can't use async list util because that'll make data ownership a little weird, but fundamentally the idea doesn't sound bad of just having something that is referenced by your adapter, just paging content in from the background. SQLCursor has paging. Can't we just wire those together? And in asking that, we actually found a lot of surprising behavior about cursor, about SQLiteCursor specifically. I came into this without a whole lot of personal experience with SQLite, or especially on Android, and I kind of had this knowledge that, like, okay, SQLiteCursor, it will page in chunks and whatever, and I just kind of assumed that it would be very easy to work with. But I found a lot of surprising details. So first of all, SQLiteCursor can't resume its previous query. There's no transaction held open, which is pretty intuitive. Like, you don't want to hold a database transaction open while you're scrolling through, but it also doesn't have any special logic in it to resume its query from before. It actually restarts a query when it's loading a new page from scratch, scans through all of the results that it's already seen, and starts reading at that new position. Now, this isn't terrible. This is just like the offset keyword in SQL. It's not the end of the world with relatively small queries, but as your load size gets larger, as you're paging in hundreds of thousands of items of data, you start paying to just traverse those rows in finding what you want. So the second part, the entire query is counted, and this is a little bit like the previous issue here, where SQLiteCursor calls get count at the very beginning to scan the entire query. It's used for boundary checking, so it can't be skipped at all. And if you have 100,000 items in your list, you don't really need to know that at the very beginning. You don't have to scan through all of them, but Cursor makes you. So the next one is that the first window of the cursor is always red. So if you have, say, killed an activity, if Android's killed your activity because it's very far down in the recent stack, you open it back up and the user is halfway down the list. What you'd want to do is load from the database around where that user is. Well, what Cursor does is it will first read the first window in the database as part of that counting scan at the very beginning, and then immediately, because your very first call will be to access the middle, it'll throw that window out, you'll do nothing with it, and it will have been wasted work. So we thought to ourselves, okay, well, we mostly understand how this works. We can still work around most of these problems. But the way that cursor load behaves is actually very surprising. So when you move to a particular position, you'd think, I've loaded the first window, I want to start loading the second one. That's what Yiğit showed us. Yiğit wouldn't lie to us. But the window doesn't actually start there. So if you remember this image that Yiğit showed you before with the first one window and then the next, this is actually a lie. This is not really what happens. What really happens is that this is all correct for the first window. We try and bind something from the very first row in the cursor window, and we start reading through. We expect to have 2 megabytes, and then after that, load more. So we see that the subsequent binds are all efficient, but then the next bind that falls outside of that cursor window, it triggers a load that's here. It's not starting where we asked it to, and that's really strange and really unfortunate. It's actually overlapping the previous query by 1/3 of a window. So it's trying to start 1/3 of a window early, and when you think about it, the reason that they would ever do this is because they want to prevent cursor adapter from hitting the database over and over again when you scroll over a window boundary, which is pretty reasonable, but if we want to be loading this on a background thread, scanning through and converting things to POJOs, that's a lot of waste. So 1/3 of what you're loading is throwing away. So at this point we thought, okay, well, one clever thing we could do is recognize that this 1/3 of a window is very predictable. We could actually ask for 1/3 beyond what we want, and then, you know, it would just give us the position that we expect, and we would just basically reverse this behavior. Well, that's actually not very doable, because the 1/3 of a window, rows aren't predictable in size. Like, this 1/3 of a window is just a heuristic that it makes a guess on. If your window can load varying amounts of rows because your rows have like arbitrary linked strings in them or whatever, that 1/3 of a window guess is just a guess. And another issue that we have to worry about with SQLite Cursor is the fact that it doesn't track database invalidates. And because cursor adapter is such a thin wrapper around it, this is particularly surprising if you've got a list view bound to your cursor, you expect it to keep loading data, but then, surprise, you get inconsistent data because an insert happens, more data comes in, and you see the same row twice, or you see a row missing or whatnot. Now, we can work around this on the room side, but it's just something to be aware of if you're using cursor directly. Additionally, you can throw an exception if the position is invalid. If the database, when creating the cursor says these are 20 items, and you load the last page, and that one of those items has been deleted, it tries to load the last item, and it just throws. So okay, great, another thing to worry about there. And then the last issue is that you have to call close in an SQLite Cursor. And this is pretty straightforward in the room case, where you just load a little bit of data, you close the cursor immediately, very straightforward. But in the case where you want to keep that alive, that's up to the responsibility of whoever's lifecycle owns that. And that's not a really clear answer, because as Yiğit said, we don't want the UI to own this. So that means that the view model has to have some sort of lifecycle around who is killing this. And it's a lot of headache to deal with. Cursor adapter just, wonderfully fixes this problem by just saying, this is on you, I have no idea. And leaving that entire problem up to you. So why on earth is SQLite Cursor this weird and this strange? And really, a lot of this is understandable when you frame it as this was written 10 years ago as the implementation of cursor adapter. Cursor has all of these strange behaviors in its paging because this is where the implementation of cursor adapter was. And 10 years ago, we were in a much different app development landscape, shall we say. Stutters and rare consistency, like, that's fine. These are just mobile apps. Data was smaller, apps were much simpler. You're much less likely to have a background thread, like periodically poking the database, inserting and removing things, so you're less likely to see invalidates. And then also memory limitations. The fact that we had such incredibly tiny devices at the outset in terms of memory space meant that it was really useful to say that this one 2 megabyte buffer was shared between both the database batching system and also the cursor adapter's cache. So a lot of this sounds pretty terrible.
Unfortunately.
Like SQLite is just entirely useless on Android, right? Now, what's the point of Room if we can't? Well, so a lot of this is actually entirely avoidable. We can avoid every single one of these issues by just loading less than 2 megabytes at once. If we don't page within Cursor and instead use separate queries in order to page, convert objects directly to POJOs and close the cursor, we avoid all of these issues.
Okay, so after this horrible findings we had, trying to understand how Android works and why it works this way, we said, okay, we need something that should avoid all of these problems. So there needs to be some goals for this paging component that we are going to develop. Okay. So first thing, we should never have this data callback and UI callback together. We need a very clear separation between the data and the UI. And usually this works by you allow UI to observe the data. So the data can be independent, change by itself, and UI has a way to observe this and reflect changes. This also means you design it in a way that there is one data, there is one list of things, but there is potentially n recycler views. Now, it's very unlikely that you have 2 recycler views in a screen accessing the same data, but think it more like user is on the screen, they rotate the phone, now the previous recycler view will be killed, but the data is still there, the new recycler view comes up and instantly connects back to the data. So data needs to be able to leave without being able to talk to the recycler view. And finally, with architecture components, we have a class where we can say, here, this is where you put your data, which is our vModels. So whatever we come up with should work well inside vModels. The second thing, no expensive operations on the UI thread. Now, it's just super important that you never miss a frame on the UI thread. It's similar to just because you didn't commit a crime for 100 days, no one gives you a present, you commit a crime one day, you go to jail. It's very similar in the UI. You miss one frame, it looks horrible. Doesn't matter, all of your other frames are in 5 milliseconds. So there is nothing like this. We will never do cursor move to position. It doesn't matter if we provide you the cursor API or hide it behind the POJO API. We should never access cursor on the UI thread. Also, we shouldn't do things like diffing on the UI thread or doing too many object allocations. Anything that might be expensive should be done on a background thread. This solution needs to be flexible with different data types. On the left, you see an example of the context application, which has all the contacts on the phone, and user has a desire to be able to jump to any contact very quickly. On the right, you see an application like Twitter, where most of the data is in the cloud, but you want to be able to show it to the user as if it's already there. So these two has very different user behaviors. We need to support different data sources. So one example is you're in the paging from database. It should work nice. The other example is you're paging from network. Now these two different data sources have really separate behaviors. Database is something you can count. You can always know how many items you have, but it also email days. You need to handle email days nicely. Versus the network is slower. You usually cannot count. Or it also errors out frequently, so then you need to handle errors. In the database case, if your database is throwing you errors, you probably have bigger problems to fix. And then the best use case is network plus database, where data is both paged from the database and also from the network to backfill your database. We need a solution that supports all of these use cases nicely. Animations is the other thing, where RecyclerView, that was probably the most important feature of RecyclerView to have animations out of the box. The example you see on the left is the one that just flickers the screen when a change happens. This is a horrible user experience. Versus the one on the right just nicely moves rows to slide and giving the user on what happened. There's a clue on what's going on. Whatever we come up with should work very nicely with animations. Also needs to support flexible UIs. Now your UI designer or use case decides what you want to do when you don't have items. So the example on the left prefers to show placeholder items. This is like very similar to the context application case where you know there's an item there, even if it is not in memory yet, you want to show a placeholder so user can keep scrolling rapidly. Versus the one on the right, you want to block the user because you don't really want to show an empty row or you don't really have a way to count the size. So both of these user experiences should be easy to provide using this new paging component. The other part, the base user experience, as I mentioned before, should be very easy to do. So there is network at the bottom layer and the data flows from network to the disk, to memory, and finally as a view into the recycler views. This data flow should be very, very easy to set up. But if you have a special case, like you're a banking application where your security people says, no, we cannot really keep the user's account on the device, and they say you cannot persist this, the same structure should work. You shouldn't need to start using new classes and like rewrite everything that you wrote before. Come on, slides. Okay. So the other part is, of course, the performance. Now we are talking about dealing with potentially very large risks, so it needs to be very fast. If that list changes, the important part of the UI should update very fast. If we are trying to reload the whole list every time, that will never work. And also the memory consumption is important. Now you have a list of 100,000 items, you definitely don't want to have all of them in memory, so this paging component should be clever to load only the necessary parts and also cap the memory usage as you page in new content. So with all these goals and all these rules we need to do, Chris figured out a solution, and he will share it now.
There's a lot of goals to put on us, like a lot of constraints to work within. But okay, let's talk about how we go about paging in data within all of these constraints, within all of these different UX decisions that we have to support. So when you want to page data, the first thing that we want to do is we take a self-updating list that is not owned by the adapter but can be referenced, and we start that out as empty. It's pretty simple. We request data when the user gets to the end of the list, and we fetch data on a background thread. We send that data over to the adapter, and we're basically done, right? Like that's most of what we need to do. Well, the first thing that you'll encounter that a lot of simple paging systems get wrong is that new pages can take hundreds of milliseconds to load, especially if they're coming from the network, and you don't want the user to have to wait for that content. So you want to add prefetch and start loading before the page is needed. So okay, now we can call this a success. We've got the general architecture description for this as the same adapter presents list, request data when the user gets near the end, fetch data on a background thread, post to adapter. And very nicely, adapter has this method notify item range inserted, which can very efficiently just accept new data at the end of the adapter. Okay, well that's great, but we talked about paging, we talked about invalidates before with SQLite Cursor. So the database can't tell you how a previous query has been affected. If you're loaded a few pages in the middle of a query, the database says something changed. It can tell you information about individual items, but an arbitrary query, it has no idea. However, in reality, this isn't the end of the world. That's actually pretty fine. We can just reload the few viewports around where the user is viewing, and that isn't terribly expensive, and we do that on a background thread. Okay, so what does this look like architecturally when we hook that up? We have the UI thread, we have the database thread. So the database will invalidate itself first because it sees somebody has changed something. The database will send a request over to the UI thread, say, okay, where do I need to load? And the UI thread will inform it. Then the database can pass the new list over to the UI thread, and that's the update system. So now we have two lists, though. This is sort of the last problem. How do we tell RecyclerView about updates? And I know what you're all thinking. Yes, there is one perfect API for exactly this scenario. Adapter.notify dataset changed. So adapter.notify dataset change is a very interesting method. It's basically telling the system that it's telling the system that I have no idea what changed, but something did, so do whatever work that you need to do to make the end state okay. You'll very often get bad animations. You'll get unnecessary animations where one item will crossfade with itself, and you'll get like a little tiny bit of a shimmer, and a lot of unnecessary bind work because every single, like say you insert a single item, every single other item on screen doesn't need to do any extra binding, doesn't need to do extra invalidates or layouts, but they will if you're using notify dataset change. Okay, so there's actually a better UI, API, and that is diffutil. Diffutil can diff two different lists. It can be a little bit expensive because it can detect any arbitrary change in one list version to a next. So say somebody deleted every other item in the database, well, diffutil would say, yes, remove this one, remove this one, remove this one, and it can send that result to the adapter. It's a little cumbersome to use though. So let's talk about how we wrap this all together in the paging library and how we try to make this as easy as possible. So page list is the first component of the paging library, and this is the self-updating list that loads content gradually. It loads data from a data source, which provides data. This is, for example, something that you could get outside of Room, get from Room, and page list and data source together form a sort of snapshot of loading state. So while a page list can load more data, it never loads data in such a way that invalidates anything that it's loaded before. It only appends. We have an adapter, the page list adapter, that handles new pages and new lists. So there are two different types of loading in the system again. There's the loading of a new page, which just is a simple, cheap append, and then there's a new list, which is done on a background thread, creating a completely new list, passing that over, and handling that with diffutil. And then there's diff callback. Diff callback is our simple wrapper around diffutil that allows you to specify how do I diff two items without having to worry about any of the details of threading, passing it around to a background thread and whatnot. So let's look at an example of what these actual classes, how these actual classes interoperate with one another. So say you have the UI thread and the background thread. You'll create a page list adapter that'll start empty because it doesn't have any data in it, and you'll create a live data of a page list. And if you're using Rx, this would be a flowable or the equivalent. And then on the background thread, we would also get a data source factory that loads information from Room. So this is how we communicate with Room or whatever backend that we're communicating with. The page list adapter will start observing on the live data, and that signals the live data, hey, I need to produce content so that this observer can display it. So the data source factory will then produce a data source and wrap that with a page list. The page list is the UI list component, the data source is the loading component. The data source will then fill that page list with data, and the page list has 40 items. We do that before we send it over so that we never present empty lists over to the UI thread if at all possible. So then we pass that over to the UI thread through the live data, and the page list adapter then acquires that, displays 40 items, and immediately presents those to the recycler view. All of this is done entirely automatically by just subscribing to the list, to the live page list, and connecting it to your adapter. So now we want to talk about the actual implementation of paging. Well, say the user's scrolling on the device, and we get near the end of the loaded 40 items that we initially loaded. Well, the page list will send a request over to data source, and data source will respond back with a new page, 40 items that it loads on the background thread, and then asynchronously will pass back to the page list. The page list displays 80 items now because we efficiently just tell it notify item range inserted, and the adapter displays those. So let's talk about database updates. Now, in a case where you have a swipe action, say deleting an item from the database, we want that to be as simple as possible. You don't have to write any code communicating from the database all the way to the presentation layer. All you have to do is, on a swipe, enqueue a delete. So what happens when that that item is deleted in the database knows this table that someone is observing is now invalid. So let's look at this example again, where we've colored all of the components that were showing what used to be the previous state of the world as green. The data source invalidates itself. It says, oh, one particular row is invalidated. One particular row has changed, so I can't load anything anymore. We get rid of the data source, and we'll create a new one that we initialize a new page list with. We send that over to the UI thread, which now has a reference to two of these. It has the old one and it has the new one. And again, diffutil to the rescue here. We send both of those over to diffutil, get a result back, and then apply the result to the adapter at the same time that we switch to the new page list. What this means in practice is that all of this system has handled a row being invalidated, sending the information over, handling arbitrary diff, so it could be any arbitrary change to the database, and presenting that with minimal RecyclerView work over on the UI thread.
The one nice thing about this structure is that like the RecyclerView might be some RecyclerView that was on the background for a long time. So the version of the page list it had might be way different than the latest version, but because it does this diffing in the last mile, it can still show the nice and correct animations and update the UI efficiently.
All right, so let's talk about presentation options, these UI decisions that we want to support inside the paging library. And go in a little bit more detail. There are two different ways to present a partially loaded list in terms of how you show this information to the recycler view. So if you have 6 out of 100 items loaded, you can present this as a 6-item list. And then when the user scrolls through this list, as they get towards the bottom, a new page can be loaded and you'll add more. But if the user hits the end first, then they'll hit a barrier. They can't scroll into items that haven't loaded yet. Now prefetch mostly solves this problem, but when a new page is loaded, we can update that and allow them to scroll further. Now we have a 9-item list. There's a different way to present this exact same loading list, though, is to present it as a 100-item list from the very beginning. If you use placeholder UIs to represent the unloaded items, you can scroll through and easily scroll past where the loading has not completed yet, and even display some of these items, even if the database, or especially if the network, is not very responsive. When new content comes in, we update those items as changed, but not inserted. So the nice feature about this is that, hey, actually we have 100 items the entire time while we are scrolling. What this means is you can use a fast scroller, jump to any arbitrary position important for a contacts list. You can scroll faster than the database or the network is loading and still see something and not hit the bottom, see an overscroll effect. And that's a really important decision that's kind of up to you and your UX of which one of these that you want to present. So we leave this as an option for you in the paging library.
Back. Okay. Sorry, it's what happens when you use a web-based solution to your presentations. Okay, so this is like, we talk about a lot of theory and how we are trying to solve this problem. Hopefully it gave an understanding of how it works behind the scenes, because we are trying to come up with an API that's super simple, so you don't need to think about those things. But it's better to know what's going behind the scenes so you can make educated decisions. So I want to talk about the code. Let's go through an example. Please. Okay, yes. So first, you need to define what kind of data you are talking about. So as Chris mentioned, the paging library requires a data source factory, and Room knows how to create this. So you can write an arbitrary query, like there are no restrictions on the query, it can be any select statement, and you can tell Room to provide a data source factory. By the way, a little bit of disclaimer, the API we are showing right now is actually not public yet. It's hopefully will be public in like a couple of weeks at most, but it's very close. Anyways, so database knows how to create the data source, you give the query, and that's all. Now the second part, hopefully, second part, yes, okay. So second part is the we model, right? We said this is where we want to declare our data. Now we need a live data of page list for these users. Here I declared the type, you usually don't need it. But to get this live data of page list, we have this class called live pages builder. It's just a simple Harper class. And this requires two things. It asks for a data source factory. You can just grab one from the DAO. And it also asks for a page list configuration. Things like, what is your paging size? When do you want to prefetch? Do you want to show placeholders or not? This kind of configurations. And it has a simple one argument constructor for the common case where you want to just give it a page size and let it choose the other defaults. And then you call build on it. Now once you build this thing, actually nothing happens. It's just a configuration. Like there is no queries running because live data works lazily. Until someone starts observing the live data, no work is done. Or similarly, Like you can keep this live data anywhere in your application. If there are no observers, it will not do any work. So we construct this. The third step is, of course, we are trying to show this inside the RecyclerView, so we need an adapter. We can extend this pageless adapter class, which is a convenience class to do the work, but you don't have to extend it. There's also pageless adapter helper class. So if you have your custom adapter, you can use the helper as well. In the onBind method, please, yes. So there's this get item function, which basically returns you the item in that position. It's coming from the super class. Now here, it depends on your UI. If you, while defining your pages, if you ask it to have placeholders, the item might be null. But if you define it to have no placeholders, this item will never be null. In this case, we have the placeholder use case. We say, okay, if the user is not null, bind it to the view holder. If it is null, move the view holder to this placeholder state. The beautiful thing about using pageless is you don't really care when that item will be loaded. It's like, you know that if you ever hit this null case, you know that pageless is trying to bring that item into memory as soon as possible. Meanwhile, whenever it does that, it's going to talk to the RecyclerView, say that this row needs to be rebound, and RecyclerView do the work. So you don't need to like add any callbacks, nothing like that. Everything just works automatically for you. There's one part, the diff callback that we passed here, which is a very simple version of the diffutil callback where you have items. And if you're using Kotlin, it's super easy to implement. And if you're not, you should. So last but not least, now we have the adapter, we have the data source factory, and we have the pages. We just need to bind all of these things together. So we grab an instance of the V model, we create an instance of the adapter, and the only thing we need to do is start observing that user list and pass it down to the adapter. This is where the lifecycle comes into place. Our activity defines that this live data is used by this adapter during the activity's lifecycle so that we can efficiently update the UI, or if there is no UI, we don't run any unnecessary update work. Of course, we need to set the adapter on the RecyclerView. This is all you need to do. You declare all these pieces of machinery and it works. Then after this, you don't need to do anything else. You change the database, it automatically updates the UI. Or if you have a network source, then you implement the data source factory. Again, it just works. Now, this is even more experimental API I'm going to talk about right now. So we're trying to solve this case where you are paging from database and also from the network. It's actually a very complex problem. The current API we are playing with looks something like this. So remember the V model where we use this live pages builder? It has this new method called setBoundary callback. Boundary callback is a simple listener that gets notified when the data source reaches its boundary, that like it doesn't have any more items to load in either direction. By the way, as a disclaimer, like to keep things simple, I'm doing this in a V model. But in a real application, you probably want to do this setup in something like a repository class, not in the V model. Anyways, let's look at the API for the boundary callback. It has very simple 3 callbacks. It says on 0 items loaded, which means data source is empty. This doesn't mean that we haven't loaded anything yet. This means we talk to the data source. It says no items. This is usually the very first callback you will receive if user is seeing that data source for the first time. And this is a good time to start a web request to fetch that data. The other one is the items on front loaded, which passes you the item. So that means there is no more, if user keeps scrolling in that direction, there are no more items to show to the user. So you probably want to fetch more from your backend. Pay attention, it actually passes you that item. But just because that item has been loaded doesn't mean that user is seeing that. As Chris mentioned, we try to prefetch this, so hopefully user never gets blocked, but it might happen. But anyways, we always have the item. Based on that item, you can probably query your backend to get more items. As a very similar thing exists for the other end of the data source. So we're playing with this API. We have a couple of sample applications, and I extracted some code from this Reddit subreddit viewer application. And this is how the on item and loaded callback looks like. This is when you scroll a subreddit and you're about to, you run out of items in the database and user is about to see a loading spinner. So when this happens, this callback simply goes to the web service, passes the information, asks for a new page, subscribe it. When the data arrives, it updates the database. Something to pay attention here is it doesn't talk back to the pages. There's no callback to the pages. Pages doesn't even care. All you have to do is update the data source, and the rest of the machinery from pages will work to show what you need to show. This is the beautiful thing about having a single source of truth. You can update the database wherever you want, however you want, and the UI will show the most up-to-date data automatically and efficiently. Of course, the actual implementation is a little more complex, like you need to handle error, there's the retry case, but we will have the sample showing how you can implement all these things. But we actually tried to abstract the error handling. It turns out there's just all these use cases are very different. It became very hard, so we decided to have a more loosely coupled API where you can customize however you want to handle your errors. And that is it. Thank you very much.